Hello everyone, welcome to my channel. My name is Ahmed and I make video tutorials on how to build and scale machine learning applications to the cloud. So if you're somehow interested in this content, please consider subscribing so that you can get notified of the latest videos. In today's video, I will show you a Streamlit application I built to interactively play with machine learning models directly from the browser. I will first show you how this app works, how you can use it, and maybe learn something from it if you're a data science practitioner. Then I will show you the code so that you can learn how to build this app and deploy it from scratch. All the code is available as always on my GitHub account, and I will post the link in the video description, so go check it afterwards if you want to test this app locally on your computer, or even improve it if you want to add amazing features you can think of. Thank you guys for watching. I hope you're all set now. Let's have a look. So this application is called Playground. It's a web application I designed, and it was inspired by the playground of TensorFlow that allows you to tinker with machine learning models, specifically deep learning model, directly from the browser and to see immediate results. So I built this application to interact with different kinds of model, not specifically neural networks, but more classical models, and some non-linear classification problems. So let's get a tour. You can start by configuring a dataset. You can select a dataset from a list of 3 predefined datasets. I will start by the moons dataset. Once you select a dataset, you can select the number of samples, the noise on the train data, the noise on the test data, and then you can pick a model. I will start with a logistic regression as a baseline because it's a simple model, and I will set the default parameter. Once you set the default parameters, you will see some results on the left and the right side. On the left side, you will see the decision boundary, and basically decision boundary is a 3D plot that allows you to understand how the model works and behaves regarding specific data. For example, in our case, our model is a linear model, and the decision boundary is expectedly a line that separates the data into 2 classes. On this section, we will see some performance metrics, the accuracy and F1 score on the test data in green, and we will see the difference from the trained data. On the right side, we will see the execution time of each model, some links to the official documentation from scikit-learn if you want to learn more about this model, its API, how to use it in practice on different problems. And then you will see a code snippet, which is generated automatically based on the hyperparameters you set here, as well as the model definition. You will see on this last section some additional tips on each model, some pros and cons, and how you should use this model in general on different problems. In our case, with a linear model, a logistic regression on this dataset, we see that we have a pretty good performance of nearly 0.9 accuracy and F1 score, which is not so bad. But what we see here is that the model is not perfect in classifying these data points because this model is linear and this dataset has some non-linearity. So we kind of have a mismatch here. We can solve this problem by 2 different solutions. We can either perform a modification on our data by adding more features, or we can increase the complexity of our model by choosing another kind of model. We can start by performing some feature engineering and still stick with a logistic regression. What we can do here is increasing the polynomial degree of our data. You can do it here by adding some polynomial features, and I will increase the polynomial degree in our case to 3. And this allows you to radically change the appearance of the decision boundary. Actually, our model changes because it has a different input, and we will see this reflected on the decision boundary. In our case, our model is perfectly suited to this kind of problem we didn't need to increase the complexity of a model or pick a more sophisticated one. Sometimes feature engineering can help. Once you select a polynomial degree, you will see the change reflected directly on the code. Okay, now let's go back to the degree number 1 with the original data and pick a more sophisticated model. So I will pick a decision tree. When you select a decision tree, you will immediately see a different decision boundary. And this decision boundary is very specific to decision trees. It has vertical and horizontal lines that separate the data into two classes. And this reflects the behavior of a decision tree, which does a succession of conditionals on top of the values of features. So if I want to change the model again and pick a more complex one, I can do it as well by selecting a random forest. And what we see here is a decision boundary that resembles the decision trees. However, it's a bit smoother because a random forest is a bagging of different decision trees, and the way a random forest classifies a data point is by an average mechanism that smoothes the result of an individual decision tree while reducing the variance. Okay, if you look at this selection, you will see different kinds of models. You can choose a gradient boosting, KNNs, naive Bayes, SVMs, etc. You can even pick a neural network. Let's do this. You can choose the number of layers. I will pick, for example, 2 layers, and you'll have to set the number of neurons to each one. So we will immediately see the result depicted on the decision boundary. Basically, this application allows you to tinker with different models, different hyperparameters, different dataset, and it allows you to understand many things. It will allow you to build first intuitions about the impact of each hyperparameter on the result, on the execution time, on the performance metrics. You can also compare models regarding performance metrics, training time. You can also see the individual impact of each hyperparameter. You will understand also effects of overfitting, underfitting, etc. Basically, it's a playground that allows you to diagnose diagnose many models on different types of data. It's not meant to replace textbooks. It's to help you. It's meant for educational purposes only. It is meant to improve your knowledge about these different artifacts. So take it as it is. All the code is available on GitHub so that you can check it online. You can go clone it, run it locally. You can even use it to deploy it on Heroku with your account. And if you have ideas on how to improve this application, if you want, for example, to add more models or more sophisticated dataset, feel free to push a pull request or create an issue, and I will be more than happy to discuss it with you. Okay, now that we see how this app works, how we can use it, let's have a look at the code, understand how these different filters and different graphs has been created, so that you can understand how you can manipulate a Streamlit code and how you can create also your own projects. Okay, see you in the code section. Okay, now see, if you want to start this application on your local computer and start tweaking it or maybe adding new features in development mode, I encourage you to go to my GitHub repo and clone this project locally. So once you've done that, you'll have the structure of the project, and you will see inside the structure 2 files, pipfile and pipfile.log. These will handle the dependencies of your project. So to replicate the same virtual environment I've used, I encourage you to have pipenv installed on your machine. And once you have it, you will go to my GitHub repo, and then you'll have to launch this command. Basically, I have run this command. I don't have to run it again, and you'll have to do it to install and create the virtual environment with the different packages. I'm using different packages in this project, so let me show you. I'm using, for example, scikit-learn, Streamlit, Jupyter, etc. And if you want to have the same packages, I encourage you to install them as well. Okay, now that you have installed your packages, you'll have to start the application. So the command is streamlit run app.py, and this will start a local server on this port 8501. Okay, so let's now have a look at the global structure of the code. Open up the project in your favorite code editor. I'm using VS Code. So what we see here is the two files I've mentioned. There are other files, procfile and setup.sh. We will see these files later on. They will help us deploy our application. And then we will have a structure with app.py, which is the main script that will start our application. And this script depends on additional scripts inside the utils folder. So we have two scripts here, the UI.py and the functions.py. The UI.py is a UI functions that will be responsible of displaying different UI component of the app. So let me show you here. For example, this is a UI component. This is a UI component. This is a UI component as well. So these are different components that can be handled separately in individual functions, and I put these different functions inside this UI.py for more clarity. Inside functions.py, we will see we have additional files to generate the data after selecting a dataset. We will have code to plot the decision boundary and create the plots that we see here. And then we will have also a function to train the model and return the train metrics and the test metrics, as well as the duration. We'll have additional information such as transforming an image path to a binary object. We'll have some information, some function that will retrieve informations about each model, such as the tips, the documentation as well. And these information are inside the models folder that we will have to see shortly. All right, as I mentioned, there is the UI script that contains different UI function. So for example, the introduction is inside this function. Okay. We will have also a dataset selector, which is this part inside the collapsible object. We will have also the model selector inside the collapsible section over here. And we will have the generate script method that will generate the scripts of our model as well as our dataset. All right, so we have also the footer that displays this part, and we will have the polynomial degree selector here. So if you want to break this application into two big parts, we will have the sidebar here and the body part here, and that's how I structured my main file. If you look at the main file, you will see that inside my main function, I will have two function calls. The first function calls is the sidebar controllers that is responsible of displaying all this information. And I have a body call, body function that will have these parameters to handle the display of these different elements. So the sidebar controllers is dynamic. If you choose, for example, a specific dataset, like the blobs dataset, we will have a specific option here that we won't see on the two other datasets. If you select a specific model, you will see its respective hyperparameters, and these hyperparameter changes according to each model, obviously. So we want to take into account this dynamic feature, and this is implemented inside the sidebar controller. All right, once we select a model, a training and the dataset, a training is executed automatically on the data, and the training is outputted by a decision boundary as well as some metrics. Some function will be called to display this decision boundary and these two charts, and another function will take this information and display it on the UI. So we will see this in more detail. Okay, so as I said, let me show you the first sidebar controller. So the first sidebar controller is, it will take the dataset selector. So the dataset selector is an object I created in the UI script. I will show you what it does. Okay, so let me put these side by side. So inside the dataset selector, we will have a beta expander that will allow us to collapse our dataset here. And inside this expander, I will put a select box and choose a dataset from a list of 3 options. And then I will have to set the number of samples by a number input here. I will have to set the train noise and the test noise with a slider here and here. And then if my dataset is a blobs dataset, I will also add the number of classes. Otherwise, the number of classes is none. Then I will return dataset, number of samples, train noise, test noise, and finally the number of classes. These objects are returned here, and then I will call inside the sidebar controller the model selector. So if you look at the model selector, it's basically the same thing. You'll have to create a beta expander to collapse these information. Actually, this is fairly optional. It's only for layout purposes. So inside this expander, we will have a selector, select box, which is choose model, and you'll have to choose from this list of different models. And once we select a given model, we will have a model that will be returned by a method. And for each kind of model, type of model, we will have a specific parameter selector that will return this layout. As you can say, this layout here depends on the model. So, for example, a decision tree has a max depth, criterion, mean sample, etc. This logistic regression has different parameters, different number of parameters. So to take this into account, I created for each model a specific Python file that will plot this information. So I put everything inside a model folders. For each individual model, I created a file. So let's see an example. For the logistic regression, I will have a select box with these different solvers, penalties, and the C parameter. And finally, once we set the different hyperparameters, I put them inside a params dictionary, and then I will put this, unroll these different hyperparameters inside the model, and then finally return the model. So basically, I'll have to do this for every given model. I think for simplicity, it's the best way. But if you have other recommendation regarding how to do this in the best way, feel free to post something in the comments. So let me show you just another example. If I want to build the same thing for the random forest, so I have to do basically the same filters, return the parameters inside the params dictionary, and then put these parameters inside the model. Okay. So now back to the UI. Once we return the model from the model selector, we will have the model type, which is the name of the model, and the model object with the specified hyperparameters. Now our model is not trained yet. We'll have to generate some data, and this data will be generated given the data set that we have selected, the number of samples, the train noise, and the number of classes. So let's have a look at this generate data function. So this generate data function is inside the functions.py. It's not a UI functions, it's more of a utility function. So basically this function takes these different arguments. If the dataset is a moons dataset, it will have to call make moons from scikit-learn. Otherwise, it will have to call make circles or make blobs, which is fairly easy. And then finally, it will return the data, train data, the X, and the targets, the corresponding targets. Okay, so once we generate the data here, we will add for the side controllers the feature engineering, which is a simple number input. And then finally, we will display the footer here. Okay, so now that we have accessed all the data we needed from the sidebar controllers, we have to input these parameters inside the body function that will handle the display of these different results. Okay, so inside our body function, we will first call the introduction, which is a static layout of our application. And then we will create two columns with the beta columns method from Streamlit. And basically these two columns are here and here. The first column will hold these graphs, and the second columns will hold this information, the snippet, the duration, as well as the tips. So inside these columns, I will put placeholders. Basically, placeholders are a way to implement dynamic data. So at the beginning, placeholders will not hold any data. They are empty containers. And once the related information are updated, they will get re-rendered. Okay, so I will call a plot placeholder inside the first column, and this placeholder will contain all this information inside one graph. Inside the second column, I will have different placeholders put the one after the other, a duration placeholder, a model URL, a code header placeholder. So this corresponds to these different sections, basically, etc. So we have 6 placeholders that correspond to these 6 sections. Okay, now that we have created and defined our skeleton, our architecture, I will add the polynomial features, if any. So if the degree is still 1, we don't do anything. Otherwise, we increase the features by adding polynomial features. And then I will fetch the model URL from a model type. So I haven't showed this to you, but inside the models folder, I have also a utils.py, which is all the metadata I need to display for each model. Like, for example, the model imports, the model URLs, or the model information in forms of snippets. So I get my model URL here. Then, as I have my data that has been generated inside the sidebar controllers, I will train my model. Okay, I will train my model to get the train accuracy, the test accuracy, the train F1, and the test F1, as well as the duration. So once I have this information, I can put it inside a metrics object, and then with this same information here, I will generate the code snippet. I will also get the model tips based on the model type, and then I will plot the decision boundary and metrics and put them inside a plotly figure. And once I have all this information, I will put them dynamically inside the different placeholder so that my layout will update every time I change something here. Okay? So, for example, I will put the plot, I will put the figure inside the plotly, the plot placeholder. I will put the duration inside the duration placeholder, and so on and so forth. Okay, so I haven't shown you the train model function. Let's see it. Okay. Okay, basically the train model function will take a model as input, the train, the x train, y train, as well as the x test and y test. It will fit the model, calculate the duration, get the prediction, calculate the train metrics as well as the test metrics, and send all these results back. So pretty simple. Now for the generate script, it's inside the UI, and basically it will get all these parameters. If the degree is higher than 1, it will perform some feature engineering. If once dataset is selected, it will import it accordingly from scikit-learn, and then it will concatenate all this information inside the snippet, and this is returned in form of a string, but to display it in form of a code, you'll have to call the code method from Streamlit. Okay, so now the last thing, maybe the most important one, and the thing that has the most value in this project, is the plot decision boundary and metrics. So plot decision boundary and metrics is a function that will be responsible of displaying the decision boundary as well as the different metrics on test and train data. So this function will be called inside functions.py, and it will take the model, the train, and test data, as well as the dictionary of metrics. So for example, first of all, it will start by computing the x minimum and x maximum, as well as y minimum and y maximum to scale the boundaries of the decision boundary plot. Then it will compute a grid of x and y, and for each x and y, it will predict the class of the corresponding point. So this will be a way to visualize the color that we see here. In fact, if you see an individual data point, it's a combination of x, y. These two elements are integrated inside the model, and this model predicts the output. And the output is either class 1 or 2. And if it's class 1, it's red. If it's class 0, if it's class 1, it's green. And if it's class 0, it's red. So I won't bore you with the details. If you have, if you're interested in how to play and display this function, you can have a look at GitHub. If you don't understand something, feel free to contact me either on GitHub or by posting a comment in this video. All right, so that we have everything wrapped here, everything communicate with each other. We have plots, we have graphs, everything is dynamic. The key idea here is to create placeholders so that your data can refresh according to the changes you made here. If you have ideas on how to improve this app, if you want to make it better, faster, or even with more features, feel free to reach out. Okay, so now that our application works locally, now that you understand how to put all these different UI components together, let's see how to deploy this application on Heroku so that it will be accessible on the internet and everyone can use it. So to deploy our application, our Streamlit application on Heroku, we need to configure 3 files. First of all, the first file is the requirement.txt, which is the list of requirements of our projects. If you want to generate this automatically, there is a quick way to do this by calling the piprex script. And basically to have this, you'll have to install piprex beforehand by using pip. And once you have piprex installed, you'll have to go inside your projects and run piprex. And this will generate a requirement.txt automatically. All right, so this will generate our first file. Then the second file is the setup.sh. So basically, there's nothing to do here rather than copying, pasting this file. It will configure some parameters on the server side on Heroku, like disabling course, setting a port, etc. So copy paste this. And finally, the proc file, which is the way Heroku will start your application. So same thing, you'll have to put the name of your entry file here and keep the other as it is. So once you have this, you have to put your project inside a GitHub repo, for example, and then you'll have to create an account on Heroku. So, for example, I have already deployed my application, which is accessible on platform-ml.herokuapp.com. But let's do this with another name. So you'll have to go here. After creating an account, you'll have to create a new app. So I'm gonna call it Playground ML2. I will select a region and then I will create the app. And then once you go here, they ask you about the deployment method. So you'll have to connect to something like, for example, Heroku CLI or container registry, but I'm gonna use GitHub because my code is on GitHub. And I will put the repo name, which is Playground in my case. Okay, so I can connect my GitHub. Then they will ask me about the branch to deploy. All my code is on the main branch, so I won't change this. And then finally, I can deploy my branch by pressing this button. You can enable Heroku to automatically deploy your branch once you push changes on the main branch, but I won't do this. So once I press deploy branch, so it will start building the container image of the dependencies of my project, and then it will deploy it. So this is maybe the time to grab a coffee and come back when this is done. Well, after a few minutes of building, the app is finally deployed, and you can check this by pressing this button. And indeed, it's deployed. We have playground-ml-2, heroku.com, and if we test the application, it works. If I select another model, let's say decision tree, it changes, and the app seems to be quite fast as well. All right, so we've seen in this project how to put in place a Streamlit application, how to compose the UI with different dynamic data, layouts, graphs, snippets, and so on. We have seen also how to deploy this application very easily on Heroku. I hope you guys liked this video. I hope it will be beneficial to your project. If you want to improve Playground, feel free to do it. You can create pull requests, issues. If you have problem running the code, don't hesitate to communicate an issue or send a comment in the comment section. I hope you guys enjoyed this video. If you like it, please consider sharing it to your friends or colleagues, or maybe hitting this like button. Thank you guys for watching again, and see you in next videos.